how do
branch
we,
and
this is for
get
representing
it
a
to
set,
turn
which is
over. Some
relatively easy.
hardwoods are better with
A challenge
a spring set.
to sort
Some
of set
are
ourselves up for,
different.
but we need
If
a little
you
more
can
work,
figure
is
it out
to make
with more
sequence
work,
binary
maybe
trees.
you could get it to clone with leaf still on
So
it.
suppose
Do
I
an
have a
air
binary
routing.
tree, and
Air
what I would
layering,
like,
right?
mentioned at the end of last time, is that I want the traversal order of
Bottle
my
around
tree
it on the tree branch when
be
she's alive, and then plant that in
sequence
the ground
order.
for a bonsai. You know, and there's
The
a
order that I'm trying
subtree
to
to that
represent that's
type of that
changed by
model where it would
operations like
be
insert F.
physically applied to the same model as gravity to get
And
that tree
so
to
I'd just
grow.
like to do the
from
same
the seed.
thing, but now I have to think about how do I do
Corn
search,
and
how do I do
the
insert at,
green
that sort of thing.
revolution is
And here
obviously
is the
cell
algorithm for what I
polarized
would
Carl
like
Sagan
to work, but it's not going to.
models from
quite
different
work yet.
indexes.
So suppose I give you a subtree.
Where are you?
So, what is that?
Specified by
Do I
the
have
node.
it in here?
So
You
there's all
might
the
not have it in here.
descendants of that node.
Probably
to
don't.
And
the
I'd like to
difference in
know
infinities
what is
between these
in the
numbers right here.
traversal
Still have
order of
limits
that
if they're
subtree,
round to
which
the
starts
decimal.
here
Because
and ends
obviously
here,
there
and
was some
the
kind
root
of
will be
limits
somewhere in
there,
the middle.
ones and zeros to
Give me
positions
the ith node.
before things automatically
If I ask
reset
I
to
equals 0, I want
whatever
to get this
application
leftmost
limit,
descendant. If I ask for
battery,
I
wire,
equals
light
the size
bulb,
of the tree
There we
minus
go.
1,
That's
I
what I'm
want to
looking
get the
for.
rightmost
Yeah, that's the
descendant.
one.
That was the first and last in the
Sorry,
subtree.
Laura.
super palm.
We talked about, but we
Get the
don't.
node.
We know how to find the first and last. Just walk left or walk right. But we don't know how to find the ith node in order h time. That's the goal right now.
You might
Not
be moving
log n.
this way, gravity's affecting
And
you this
the
way,
idea is,
binarily, given the
It seems
qubits
like
in here that
size
you'll need.
matters. Sorry if you heard
Yeah,
otherwise.
Right.
So in particular, I mentioned size when I was talking about the last node in the
Interesting.
sequence.
Yeah,
That the
sometimes
index
it's
of that node
this scale
is
right here
size of
because
the
that's what
subtree
GPT-3's
minus
got, and you got to
So let's
figure out all
define
this stuff and make it work.
the size of the node.
The Soviet Germain, you got to make it work.
Still broke 1, 2, 3,
Breaking
4,
dark
5,
conjecture,
the number of
Picure.
nodes
2.
in
This
subtree.
is
There's
chaos
lines,
theory, I
like,
believe. I'm not
subtree.
100% in there. This is order theory, maybe.
What are we doing here? This subtree
Maybe
F,
that's Couch's
you
theory.
could
I'm
be
not
a
for sure. I can't tell from here.
and the
Including the node
size of
itself.
the
There's been a few
node
keepers
here.
So if
inside
I
here
somehow
on the
knew
white
size,
team.
this seems
Or
important
basic
for
algebra
embedding
trig.
indexes. Let's just assume that
Geometry, I
knew
think,
that.
is what that is. Some
Magic
calculus,
I know it is
order or
because this
chaos,
becomes
order
a
theory, and
then
then
a whole
I claim
write-off.
the
Couch's
size
theorem, I
of
think
the
is what
left
that
very
is.
subtree, so
basic
what am
thing
I
you'll see
Sonar.
people repackage a lot. And
Ping.
little variants
Based on
size,
some of the
shape,
brick and
scale,
jar
Yeah.
algorithm stuff.
them very correctly
How
done
to code the
model,
topology
MITs
on mass
adjust
bin,
the
or
buddy,
how you got it angled to Princess Peach here.
They might not exist.
Great.
But let's
That
ignore
raised part
those
of it.
exceptional cases for now. Let's suppose
Here we
we
got
knew
Ying's-Wheel's
not
mass
only the
gap.
size of
Right,
node,
so
but
this
we
is
knew
my
the
white
size
bishop
of node dot
on the
left.
white
So that is
side,
the size
and
of this tree.
given
One day
on
you'll
the left.
understand. Because the reality is I'm going to
call
come
that
at you with that
NL.
kind of
So let's
information.
suppose
black
that
pawn
there are
here
NL
for the black
nodes now.
bishop and
If
B
you want to
problem.
be super pawn here,
And here,
My claim
this is
that
the
lets
black
me do
queen
the
is down.
equivalent of a binary search.
She's Russian.
Because I'm
Italy,
looking for some
she
index
runs the
I,
billiard table, and
and
I
if
bring
I
up the
is
bar
less than NL,
sometimes
then
all
I
the
know
numbers
that it must
work
be down
on
here. For example, if I equals
the
0, it's
frames.
going to be in the left
You'll
subtree.
need some of
As
those
long
other
as NL is greater than 0.
frames,
Right?
subtrees.
So that's exactly this
Kyle
trick.
Hill
If I is
talking
less
about
than
Dr.
NL, I'm going
Manhattan
to recurse
experiments,
to the
Penn's
left.
row over here on space
Call
time,
subtree at
Wolfram
node dot
Alpha,
left,
Parth
comma I.
G, optimization
If
class
I
for a
equals
video, subtree on
We'll give that a
timeline.
second. So NL is the number of nodes here. And so that means this node has
Coding,
index.
again, crypto
NL.
stuff, and
index
what
of
do
this
we have
node
up
is
here?
And so if I
Alright,
equals if the one index we're looking for is that one, then we just return this node. We're done.
Adam's obviously salty.
And
He's taking
otherwise,
on
I is
Burrito
greater
at the
than
same
NL.
time.
And that means that the node we're looking for is in the right subtree because it comes after the root. Again, that's what it means. That's what traversal order means. So if we define it to be sequence order,
Everybody get out your
then we know
self-learning droid.
all the things that come after this node, which is index NL, must be over here. Now, when we recurse down here, our numbering system changes because for node, 0 is here, and then for node dot right, 0 is here.
The course,
So we need to do a little bit of subtraction here, which is when we recurse to the right, we take I minus NL minus 1. Minus NL for these guys, minus 1 for the root
application,
node.
subtree, you know,
and that will give us the index we're looking for within
Gauch's
this
theory,
subtree.
order theory.
Okay, so it's my point is this
particle
algorithm
spin.
is basically the same as this algorithm, but this one uses
Wolfram
keys
alpha.
because we're dealing with a set, and in the sets we assume items have keys. Over here,
we could
items
scale
don't
this
have to
around,
have
you know.
keys. In fact, we're not
If we
touching
go
the
up
items
to the
at all.
down on the
We're
reset
just
and
asking what
chessboard
is the
here
ith
and
item in
change
my
what pieces do
sequence. which is the
What-
same thing
what
as
does
what is
that
the
mean?
ith item in my traversal order, which is the same thing as asking
Somebody
what is
else
the
might
ith
get
node
here
in the
and
traversal
do
order,
topology
and this
problems
algorithm
on
gives it to you
object
exactly the same
conjecture
way
upon
in
cure,
order H time.
cosmetology, topology.
Okay, now I'm not
torus
going to
and
show you
a
all the
sphere, both
operations, but
with
you can use subtree
spin
at
and,
to implement.
mass problems internally
get
to
at
their
and set
own
at.
value of
You
spin
just
and
find the
black
appropriate
hole,
node and
white hole,
return the
neutron
item
star,
or modify the item.
G star,
Or you
given
can
a
use it
possible
to,
word problem,
most
a
crucially, you can use it to do insert
flips
at and
on
delete at. This is a
positions
new
of the
thing we've never
home
been
game
able to do
theory
before.
for
What do you
integral.
do? Just like over here, if
excuse
I'm
me.
trying to insert an
What do
item,
we got here?
I search for that item over here. So if I'm trying to insert at I, for
Integral
example,
algebra tools,
I look for I,
you know, for
and then,
printouts and how to design
yeah.
algebra shifts.
for insert at I
basic
want to add a new
algebra.
item
Okay,
just
so
before that one.
Geometry.
And conveniently,
Well, if you
we
watch another
already
one, see the
have
skid,
this is my
you
way
see the
mentioned,
skid
but we have a
steer and
subtree insert
some of the other
which
numbers
has
you
two
get with this
before
game
and
down
after.
to it.
There's the Hodges usually runs tight with topology on
cover it after.
toroses and
which is successor
pass that
before
keyhole
is
through
predecessor.
here on pipes,
But we
pop
can
it up and bounce it
just
around
call
inside here like
subtree
we do.
insert before
Special designs
that
and
node,
geometries
and
you'll
boom,
find in common
we will
with
have added a new item just
optimization
before
and
it.
the way you might see
And
3
great,
or 4
so
cells come
magically,
off
somehow,
in a little 4x4
we have inserted in the middle of this
or
sequence,
why you'd use one
and
whole
all of the
piece
indices
or
update because I'm not storing
part of the grid
indices.
for math.
Instead,
Yeah,
to
really
search for an item at index I, I'm using the search algorithm. But there's a problem. What's the
Yeah,
problem?
look at it. You look
Like
at it.
come out of there, Joe Rogan's universe. Like,
seems a
Bob
little
the Builder
too good to be
episode,
true.
not gonna happen. These guys need something
insert
real.
it in the
Roughly in
middle of
that
the tree.
sequence, you can do fun
I
stuff
can
with you
magically
playing the
search.
I
game
can go to
theory
zero.
Still
on.
find the
Like,
ith item,
if
even though all the
if
indices to the right of
you were
that item
drinking, I'd
if I
expect
want.
it to look like this, you know, on the sloppiness for what it does. But, you know, when
Almost
you're solar, you know,
That's
being in the stone mill, I could actually, my brain is there now.
Yeah.
You know, you need
Because
to
we
get
have to
used to
update
doing
the
that in
sizes, right? I
Oculus,
didn't
right?
say,
You learn it.
how do I
You
compute
go
the
to their,
size of
like,
the left
Yoda's
subtree?
home
So
tree
that is the
there,
next
where you
option.
gotta learn to face your fears and your shadow clone jutsu over here
We're
from the
almost
fell.
done. This
You
will
mean,
actually work.
this
It's
cowboy
really
over here
quite
about the
awesome.
numbers. And I
But,
was like, yeah, I'm
for
big
it to
bad.
work,
I'm
we need
bad.
something
King
called
Kong is salty,
subtree
but it doesn't
augmentation.
matter. Some cowboy come in here, wreck you in the back of the head with
We'll
a
talk about
crowbar.
generally, and then
Doesn't
we'll
much
apply
matter
it
when
to
you're
the
playing
size.
King Kong on
What are we doing here?
M1 Mod 2, M1 MM, you know,
What's
doing
this
the
So the idea with
Come
subtree
on, let me
augmentation
look at it, MIP.
is
Come
that,
on, you let me do it.
each node in our
get up in the
binary
morning,
tree
you get
can
dressed, you do
store
your thing, you get out there,
a
you
constant
dance.
number of
You
extra
dance.
fields.
Get up
You know,
in the
log mill, no problem.
not?
Or Rabbitohs,
You
right?
And in particular,
Nothing. Oil company,
if these
like, look at
fields
them.
are
That's
of
on a button
particular
toggle
type,
switch. It'll
or
wrap
maybe I'll
right
call
back
them
around
properties.
subtree augmentations. You got it. This is rock, right?
I'm going to define a subtree property.
You got
That's just
limestone.
one of them.
If you
Clock
do
in,
that
go for it.
with this
Okay,
rock
did you
the
sign
correct
it?
way, it'll 35 like a champ. I'm banging rabbits out here one on one.
To be something that can be computed.
There you go, buddy. There you go.
You are good for 1 month right here. Bang. 1 month.
Recognize this is out of my headquarters, buddy.
From
You're
the
looking at me down there,
properties
That's a
of
mile.
the node's children.
Right.
So I should say
Mario's
of a node.
Princess Peach's butt hut. Right here, you know, you got the little fire flower, star.
So children are node dot left and node dot right. You can also access a constant amount of other stuff. For example, the node itself. But the point of a subtree property is it's downward
Get
looking.
out of
If
here,
I have a
GT3.
node,
When you done? You broke. You
He's Combat 7 drone. You can get in your Oculus
I want to compute
homeworld.
some property
you could,
about
yeah,
it.
I mean, with your
Call it,
vehicle for your programmer
want
bone
store
structural
P
engineering
of
to
the
drive
node.
it. There's no air here.
And suppose we already know
There we go.
P over here, the property computed for the left subtree or for the left node, and we already know the property for the right node, then what I'd like is for this to be computable in constant time. So I can compute P of this node
Punch you in the
given
ribs hard
P of the
enough,
left
but
node
you
and
got
P
that
of the
fucking
right
helmet
node.
on. I
That's a
bet you pay
subtree
attention
property.
very-
Now in particular, size